So YouTube, today I'll be making a tutorial on matrix rotation. So what I'm going to do in this tutorial is I'm going to show you how to do a matrix 90-degree rotation, in this case clockwise. You can easily adapt it to be counterclockwise using specifications of O of n time, or you could say O of n squared depending on how you're keeping notation, and O of 1 space. So I'm going to go against the O of n squared time just because for the sake of this I'll show you how to do it for rectangles and for non-rectangles, so then you could argue it's O of nm, where n equals the width and m equals the height. So the first step is we're going to get a matrix and I'm going to show how this algorithm works. So I'm going to show a couple examples of what I'm going to try to achieve here, and then I'm going to switch over. Let's actually, let me just quickly change the type of paper I have so I can make it grid so you guys will like it more. Okay, so let's take a matrix. Oh, 4 by 3, okay. So let's have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now if I try to rotate it 90 degrees, clockwise, so like this, 90 degrees, what I'm going to get is I'm going to get the following matrix. So this is a 4 by 3 matrix. I'm actually going to get a 3 by 4 matrix instead. So I'm going to have a 9, 5, 1. Over here I'm going to have 10, 11, 12. Over here I'm going to get 6, 7, 8. Then we get 1, 2, 3, 4, like over here. So over here we had a 4 by 3. And then it became a 3 by 4. And this is a main distinction between what other people's algorithms will do. And I think this is something very important. So we see here that we're changing the type while we're converting it, which is something very essential. And we have a 4 by 3 here and a 3 by 4 over here. So here are the steps for doing this algorithm. There's basically two important steps. Number 1, take the transpose of the matrix. Number 2, revert or reflect rather matrix columns. Okay, so you may have never heard of the word transpose before. No worries, we're going to go over the definition of transpose right now. So let's go over it right now. So transpose. So we take a matrix A, and we take a matrix of indices ij. We take its transpose, and this will be equal to ji. So let's take a concrete example of this. So we're taking, we see over here, I'm taking the indices ij. These are the indices. So like you can think of it as like the x and the y. This is the transpose sign. And now we're saying this is ji. And we can say this for all I and j. So if we have a matrix 1, 7, 3, 2, 6, 5, 8, 4, and then we have a, what's the missing number here, 9. And we're going to run this transpose. We're going to try to flip. So here we have an index right here. For example, this guy. This guy has a x coordinate of 0 and a y coordinate of 1, right? So by doing the transpose on this guy, what we're saying is that ij becomes ji, right? So by this logic, this should become 1, 0, and 1, 0 indexed over here. And similarly, 1, 0 becomes 0, 1, so this guy goes over here, so these guys flip. Now if we go over to this guy, over here, well, this guy is 2, 0, 2, 2, 1, so this guy becomes 1, 2, and 1 is over here in this column, 2 is over here, so this guy flips over here. So what we notice immediately is we're trying to get like a reflection over the y equals x. So we're getting what we're essentially doing here is we're doing a reflection. So we're gonna keep these the same, and we're gonna flip these over here, like so, and we're going to be reflecting them. So this will be the transpose operation that we're going to get. So now that we have taken the transpose of it, we're going to do the transpose, and now we notice that, let's take our quick example over here. If we do the transpose of this matrix, actually, taking the transpose of this matrix is a fairly tricky concept. So we're getting this 1 over here. This is actually 0, 0. So when we go over here, we actually notice that 0, 0. If you notice in this matrix over here, the 0, 0 matrix isn't still 0, 0, but this matrix is not here. It's actually over here. So one of the properties we'll notice is that actually this is wrong, and we actually need all of the columns to be flipped. So this is 0, 0 over here. This guy over here, this guy is 0, 1, becomes 1, 0. And 1, 0 is here. This guy's right. This guy over here, well, this guy is 0, 2, becomes 2, 0. Flips over here, 0, 2. So this guy is actually 0, 2, becomes 2, 0, but, well, unfortunately, 2 zeros over here, which is not quite what we're looking for. We were looking for this guy to be over here. So what we actually notice is, if we actually look at this, right, we notice that this actually becomes a flip. So the matrix we're getting here, the matrix we got from the right side, actually has all of the columns flipped. I'm not going to provide a proof of this, but the matrix we would get if we execute only the transpose algorithm would be 1, 2, 3, 4. Then we would get 5, 6, 7, 8. If this column is right, 9, 10, 11, 12. So we did the transpose, which was step 1. Maybe I should move this over to the other side. We did our we did our transpose, which was step 1, and it bundled in the E. No. So we did transpose, which was step 1. Now let's head over and do step 2, which is discuss the reflection. Now this is very simple. So we just simply take every single column. So if I have any random numbers here, and we do this operation of reflection. We're just going to copy all of these numbers over like that. So enough talking, let's actually get into the code implementation. So one thing I have to notice before we actually get into the code is how are we representing our matrix. There's different ways of representing it. So how data structure used. Well, ideally, we want all one access time to everything. So what we could use is, well, we could use a hash map. That's not any use to us. So we have two options, but pretty much we have two options. We have option I, which says we can use a 2D array, which is more of like a matrix-like operation, or we can use a 1D array with a map function. So I'm going to discuss why the 2D array might not be good. So the 2D array technically would have to take up n squared time, where n is the max of n and m. So if we have a matrix, so for example, let's say we have a 4x2 matrix, we'd be taking up 4 times 4 space, which is not very good, right? So if we have a, let's say a 1x4 matrix, we would actually technically be taking up, significantly more space than we're supposed to. But how does a one-dimensional array work in this case? Well, a one-dimensional array is actually slightly more complicated. So what we're going to do with a one-dimensional array, the idea behind 1D is we're going to get, so let's say we're trying to represent, let's take an example matrix that we're trying to represent. Let's say we're trying to represent this guy over here. So we're trying to represent this guy over here. Whoops, whoa. Let's do this. Okay, this guy over here. So So what we're going to do is we're going to get a matrix. This guy over here is 3 by 3, right? So this will get us 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to go in order. So we're going to go in this order. We're going to go like that, and like that. So we're going to say 9, 1, 7, 8, 3, 3, 2, 4, 2. So if we're looking for specific index, I'm going to do a little bit of code now. So for code, we use language Java. So in Java, if we want to map index x, y to ith index in the array, well, we need to know the height first and the width before we can accomplish this. And after that, we can quickly figure it out using a simple formula. So intuitively, the formula is actually x plus y times the width. And you can try it out for yourself if you're curious to see how this works. Just recall that we're actually working in 0 indexed. So we have 0 index over here. So we're going to create a function called, let's say, we're going to have a function called map. So we're going to return an int. It's called a map. Int x, int y. And then inside of here, we're also going to have, and I think this pencil is a little bit thick. I'll keep it. Actually, yeah, let's do a bit thinner. Int width. So I'm going to pass in, this is all we really are interested in. We're going to return x, x plus y times the width. And that's it. Okay, so we got that going. So now we got this map function that maps it to our handy dandy array. So now we want to implement the first step in our algorithm, which we said was the transpose. So let's do our transpose function. So we're going to do a void transpose on an array. Let's assume that the width and the height are global variables. So global variables width. Alright, so what we're going to do is we're going to first iterate through. So when we're taking the transpose, we were going through, we noticed that we have this relationship where we're actually only binding it through the y-axis, like we say here, like that. So what we're going to do is we're actually going to scan through the elements like this, greedily. So we're going to bind it through like this, and we're only going to scan through the items that we're passing. So what we actually find is we can actually set up a normal for loop. So for int x, let's go by the height on the outer side. And then we go through the x. If x is less than or equal to s is invalid syntax. Y, continue, we're not interested. Otherwise, let's get our temp. So we can say int coordinate a actually. Well, this is just simply map of our x, our y, and our width. Now we want our sister coordinate into our x, y, and the width. So if we take our matrix over here, give some idea of what I'm doing here. It's not just random stuff. If we're located over in this index, well, we said that this has coordinates of x, comma y, right? So we want to get to this guy over here, which is y, comma x. So the way we do this is we just simply flip these around. Okay. And then let's get our temp variable to do a swap. and we say array. And we say array, chord B, and we're done. Now we just have to do the last step. So now we did the transpose, we're done. Now we just have to do the rotation for the columns. So again, this is relatively straightforward. This time we're going to try to bind it on the columns going inwards like that. So we're going to try to go inwards. So let's say void reflect columns. So what we're going to do is we're going to go through all of the columns, which we're actually just going to go through the width divided by 2. Now we need to go through each of the rows as well, like this. So we're going to iterate through the height. And what we're going to do is, actually, let me move this slower down. Whoa. Oh, shit. Oh, sorry, bad language. Can I undo? Oh, no. Oh, not too bad, though. Could have deleted worse stuff. So what we're going to do here is we're just going to get the int chord A equals map of x, y, and the width. I guess since I said it was a global variable, there's no point in having the width over as a parameter, but whatever. Now here, this is a little bit more complicated, so we have our x value over here. We want to get this guy over here. This guy is actually width minus x minus 1, y with width. And now we copy this guy over here. Copy. Paste. And I can delete this guy. Like this, like so. Nice. Move my if statements up. So here we go. And we got it. So this is the reflect columns, and then we just have to invoke these two functions. We got the transpose of an array, and then we reflect the columns. So we just call, if we have any array, of whatever size, we can initialize it over here. Then we say transpose array, and don't forget we also had the width and stuff over here. So width, and here we have reflect columns. And yeah, there we go. So the final result that we get, we have O of n times n time, O in space, additional space, because all we do is we do these temporary variables over here. And in fact, you can actually get rid of the temporary variable, even though it's complete nonsense, but you can use XOR optimization using XOR swapping method. You take the XOR of the two values, so then whenever you do XOR again, I don't even know why I'm saying this because it's not applicable to this tutorial at all, but you can get just B, so you can actually eliminate one of these lines over here. But anyways, O of n times n time, O of one space, and don't forget the two steps that we have over here. And yeah, that's pretty much the tutorial. Thanks for watching. Hope this helps. If you have any questions, leave them down below. Please like and subscribe, and thanks for watching.